A railcar mover is a road rail vehicle, capable of traveling on both roads and rail tracks, fitted with couplers for moving small numbers of railroad cars around in a rail siding, a small yard. They are extensively used by railroad customers because they are cheaper than owning a switcher locomotive, more convenient and cheaper than paying the railroad operator to do the switching, easier and more productive than manual moving of cars. And in addition, they are more versatile since they can travel on road wheels to the cars they need to move, instead of needing clear track drive systems. Some have two drive systems and drive only on steel wheels on the rail, with their rubber tires lifted out of the way, while others have only one drive system and use steel rail wheels only to guide them and use their rubber tires on the rail. In a similar fashion to rail trucks, these systems have a higher tendency to derail while pulling loads and in curves. Traction. Railcar movers are fairly lightweight, so in order to gain more traction, some models transfer weight from the car they are hauling onto their own wheels to increase their effective weight. These models use steel wheels on steel rail, much like a locomotive, which provides a more consistent traction among wider variety of conditions. The steel wheels also last far longer than rubber tires and overall cost less to operate. In Australia, construction equipment such as loaders and telehanders are converted to shunting use, and on these machines, the boom lift is used to transfer weight from the car to the drive wheels. In Europe, trucks, lorries, fitted with railway wheels and couplings are used as rail car movers, often called towing or shunting vehicles. Manufacturers. Numerous manufacturers produce rail car movers in multiple countries. The first railcar mover was built by Whiting Corporation, now Trackmobile, in 1948. North America. Well-known railcar mover brands in North America include Trackmobile, Rail King and Shuttlewagon. Trackmobile is a well-known railcar mover worldwide and began as an in-plant project at Whiting Corporation, Harvey, Illinois. In 1947, a young ex-Navy fighter pilot and engineer named Marshall Hartelius was assigned to modify an old industrial locomotive Whiting had used for years inside their plant. Their locomotive was constantly being trapped on dead-end tracks, losing hours of productivity. Hartelius was charged to find a way to move it by road to avoid bottlenecks to railcar movements. He first designed a road wheel system to mount on a locomotive, but found it was cumbersome and complicated. Furthermore, in spite of the added utility of road-to-rail capability, the locomotive consumed a lot of fuel and oil and required constant repair. Marshall scrapped his first design and in its place submitted to his boss a concept for a vehicle specifically designed for in-plant rail movement. It had hard rubber tires to move by road and flanged steel wheels to work on rail. The central problem was how to design a machine that was light enough for road movement and yet heavy enough to start and stop rail cars. Hartelius's solution to this engineering dilemma: borrow weight from coupled rail cars to increase the vehicle weight for traction. He designed a coupler head that could be operated from the driver's seat, and that would raise hydraulically to lift the railcar, transferring up to 49,000 pounds, 22,680 kilograms, to the wheels of the vehicle. A prototype was built in 1948, and designated the Mule. Quote, "It went to work in the Whiting plant and was an immediate success. Railcar movement was accomplished in a fraction of the time the locomotive had required. It consumed little fuel, required little maintenance, and dramatically lowered operating costs compared to the locomotive." Hartelius had solved a difficult railcar switching problem for his company. In 1950, Marshall wondered if other companies might be interested in a mule. He put one on a trailer and took it around the country, demonstrating the advantages of a mobile railcar mover. Since then, more than 10,000 trackmobile units have been put into service in 54 countries. Australia. In Australia, construction equipment such as loaders and telehandlers have been converted into shunting vehicles. These vehicles can still be used for their original purpose, shoveling or forklifting, in the yard whilst not being used to move rolling stock. The vehicles are fitted with in-cab train brake controls so that the driver may operate the braking system on the train. Ireland. In Ireland, Unilocomotive has been manufacturing the range of Uniloc road, rail wagon movers since 1954. Diesel and electric, battery-powered, are available. The Uniloc carries out shunting tasks that locomotives 4 to 5 times their weight would do, but with greater mobility and at a fraction of the cost. Germany. German brands are Unimog, Zwickhoff, UMEL and Zweiweg. Italy. In Italy, Zephyr produces railroad shunters since 1977, both diesel and electric, battery-powered. Belgium. In Belgium, the company UCA produces the UCA track railroad vehicles based on the chassis of a JCB load-all, UCA Track B, and JCB Fastrack, UCA Track F. The UCA track provides traction through its rubber wheels. Gallery.